All right, case 2, where we have arc z minus z1 over z minus z2 equals pi. Well, that is the case where you have 2 points again, but this time the 2 points matter where z1 and z2 is. There's only one way where z1 and z2 could be, and in this particular case, this has to be z1 and this has to be z2, and I'll explain why. And it's actually the line between them, the part between the interval between them is your locus. And the reason for that is the definition of arc z minus z1 means the angle that the vector from z1 to z makes with the positive direction of the x-axis. And in that case, if your z is, say, let's say here, then arc z minus z1 would actually be this angle here. Let's call it alpha. And if you look at z2, then that vector there that I've just drawn is actually z2 to z. This is z, by the way, one in between. And by definition, arc z minus z2, the angle that the vector from z2 to z makes with the positive direction of the x-axis is actually this angle here. And because it's going down that way, this angle here is actually negative. But let me label the size of that as theta, right? And that theta is positive. I'm just saying the size of that, right? So by definition, arc z minus z1 is actually alpha. This is positive. But arc of z minus z2 is actually negative theta. And so if you have arc z minus z1 over z minus z2 equals pi, that actually means is arc z minus z1 minus arc z minus z2, because the arc of division is actually the difference between the arguments. That's one of the properties of complex numbers. And so if you take this to the other side, arc z minus z1, actually, if you keep it here, actually, and replace it with the alpha minus, argument of there is minus theta. Let me go up a bit, sorry. So that's alpha, that's minus theta, and the answer should be pi, because alpha plus theta is pi. Why? Because if you look back at the diagram here, that's parallel lines, these two lines. And I think these two angles are called co-interior angles. And you know, co-interior angles, parallel lines are supplementary. That means if you add them up, they equal to 180 degrees, which is in this case pi radians. And that's why the locus of the argument of z minus 1 over z minus z2 equals pi is the line between intervals. So let's give an example. Let's do a concrete example. And I think this is one in the sample HEC 2020. But I'll just make one up. Let's say 2, what the heck, plus I, and then z plus 3 minus 2i, I'm just making this up, equals to pi. And you're asked to draw that. Well, you have to change it into the form of z minus z1 because it's not at the moment. So you have to use a bit of algebra. And it's like that. And z minus 3 plus 2i. Brackets around there, brackets around that. So if you play with algebra, you get that and that. That is your z1. So that's z1. So z1 is actually 2 minus I. This is your z2, which is minus 3 plus 2i. And so if you were to draw that, let's see, 2 minus 1 is here. That's your z. In this case, z1 there. Oh, by the way, this may not work, by the way, right? So I'm really on spur at the moment. It has to satisfy pi. Minus 3, 2. So minus 3, 2. Lucky for me, it works. Minus 3, 2 is there. And so that's your Z1. That's your Z2. And the locus is actually there. And it works because it just happens that arc of Z minus Z1 is actually this one. So it has to be a certain orientation. It can't be just any willy. And lucky for me, I chose the right numbers to work. And there, so the argument of Z minus Z1 is that. The argument of Z minus 2 is this, because if you pick a Z anywhere there, that's a vector, that's a vector. And so that's the argument of Z minus Z1. And this is the argument of Z minus Z2. All right. Don't forget this is negative, by the way. And so these two will add up in size to be pi, which is 180 degrees. So it's that plus that is going to equal 0. But don't forget, in terms of size, but in terms of this, it's argument of that minus argument of that. But because the argument of the bottom is negative, you end up with pi. So you can't just win in linear, right? It has to be a certain orientation. It can't be anywhere. So, for example, if I have my Z1 and Z2 here, that won't work, because if you put join the line there, right? What I'm saying is, if you make this Z1 and this Z2, and it won't work, because the argument of Z is here. The argument of Z minus Z1 is actually this angle. Well, this angle is actually negative. And this angle is actually negative. And that brings me to another case, which is the negative pi, not the pi, which I will go through in the next video. We'll stop there.